right, and we're going to begin our lecture today with acid-base titrations. So, when it comes to titrations, what is it? What is it used for? Why do we care? Well, this is a process that we use as chemists to determine the concentration of an acid or a base in an unknown solution. The goal is to use a titrant, a known solution, to determine how much of this unknown we're dealing with. So the way that it works is that if we're trying to figure out the concentration of an unknown acid, we're going to use a base that we know to kind of figure it out. On the other hand, if we're dealing with an unknown base, we're going to use an acid that we know to try to figure it out. And so it depends on the situation, really. The goal is to know this. The concentration of the unknown is determined based on how much of the known solution we were going to use to neutralize it. In other words, if we're dealing with an unknown acid, well, how much of this base did we use to cancel it out? And then we use some math to figure out, okay, this is the concentration of my unknown solution. So let's just go over some really quick reviews before we go over an example. When we neutralize a reaction, we are producing a concentration of a pH of exactly 7. 7 with infinity sig figs. It is that precise. And so when we see that there is a physical change in an indicator, we'll know whether or not it reached that point or not. So the way that it kind of works is through that kind of GIF file over there in the corner. It's difficult to see, but the goal is to add in our known acid or base, and we keep adding it, mixing it, and swirling it until we see that there is a visible, noticeable color change. And when it comes to, hopefully there's there it is. And so the goal for us is to reach the end point. It's not too far, it's not too little. It's in this point where we see like, oh, there's a color change, but it's not super prevalent. So in this example, the color is pink. So the goal for us to notice when we hit the end point in a titration is that it is just on the cusp of pink. It is not super pink, as if it's super pink, we've gone too far. This is the goal for us to know, oh hey, I am at pH equals 7. And so, calculation time. The strategy is this. We're going to go over the problem very soon, but the strategy is that if you neutralize a solution, you would also figure out that the moles of your hydroxide should also be the same moles as your hydronium. And if you calculate the number of moles of an acid, if you're using an acid, and you divide by the volume that you use, you should get a concentration in units of molarity. So let's take a look at our example problem. Example problem 13-9. You have a solution of hydrochloric acid whose concentration is unknown. You're going to titrate it using a 0.15 molar solution of sodium hydroxide and find out that you used 15.36 milliliters of it to neutralize 50.0 milliliters of that unknown hydrochloric acid solution. How do you calculate its concentration? Well, let's take a look. Step 1, you need to figure out what the chemical reaction looks like. You need to provide the balanced chemical reaction. So here it is for you guys to see. It is NaOH plus HCl is going to yield NaCl and H2O. Next, you're going to need to find the amount of moles of your base that you use to neutralize this acid that you need to solve its concentration for. So here's what we did. This number is this number here. What I did is that I took 15.36 milliliters and I converted my milliliters of my base to liters of my base. That'll come in handy very soon, as you'll see in the next couple of slides. What did I do next? Well, I need to find the amount of moles of my base that I use. So I just multiplied that liters by my molarity. Aha! That's why I converted, because molarity is defined as moles over liters. So the liters and the liters cancel out on my base, and I end up with that number. Notice that I did not round for sig figs. We are going to worry about sig figs at the end of our calculations. At the moment, keep your numbers as is that you see on your calculator. Now, what do we do next that we found moles? Well, with moles of base, what we're going to do is find out, well, how many moles of acid did that react with? So here is the work. It's hard to see, but if you guys kind of pause the video, try to figure out what each of the numbers look like and what the units are, it's going to make some sense, because here's how it works. You have moles of your base, and through stoichiometry, yes, stoichiometry, you're going to find out that you're going to have, based on the formula, for every 1 mole of sodium hydroxide that you've put in, you're also going to make sure that it reacted with exactly 1 mole of hydrochloric acid. And so, congratulations, you have just converted moles of base to your moles of acid, and that is going to apply with what I mentioned earlier with keeping your numbers as is. Don't do sig figs yet. Just be happy at this moment that you figured out that you have now a number of value for moles of acid to work with. And then we're going to do what? Well, with your moles of acid, you need to go back to the question. What do you need to find? Concentration. You found the number of moles. You're also given a value of volume of your unknown acid that you've used. What can we do to find concentration? You have your moles of acid that you found earlier, and you're going to divide that by the volume of acid that you know that you used based on their given problem, and boom, you're going to get a value of concentration in units of molarity. But before I show you the box answer, I want to just point out what happened here. So remember, this wasn't given in milliliters, but molarity is in units of moles per liter. So now that we convert to liters, we get this value for molarity, but then we throw sig figs into account, and we have 4.61 times 10 to the negative 2 molar hydrochloric acid. And so with that said, we show that we are done by boxing our answer, checking for sig figs, checking our math. Seems legit. Cool. And it's time to move on. Now, on to our next example problem. Here's what we're given. But before we do that, I just wanted to show an alternative solution. This is the same thing that we did, but it's all together in one piece. This is your call. If you feel like you're comfortable with doing all your calculations in one go, you are more than welcome to do it. Just make sure that you guys still stick with that same message of making sure your units check out and your sig figs are legit. And you should still be able to end up with that same answer as we mentioned earlier. Okay, now we're going to move on to our next example problem. So the second example that we're given is this. You are titrating 25.0 milliliters of an unknown solution of magnesium hydroxide. And you're going to use exactly 34.21 milliliters of a 0.25 molar solution of HNO3. Calculate the concentration of magnesium hydroxide. So the strategy is the same as before. Figure out the number of moles that you're working with and try to find a concentration. So once again, you're going to assume that the moles of your hydroxide are going to be the same number of moles as your hydronium. Convert one form of moles to the other. So, just like before, step 1, balanced equation. There it is. Step 2. There it is. Balanced equation. What do? We just change that and that to make sure that everything balances out. Step 2. Step 2, find the number of moles that you've used to titrate. So you have used exactly that much volume of HNO3. How do we get that liters? Remember, we converted milliliters to liters because we need to use it to multiply molarity by our titrant. And that gives us moles. All right, now that we have moles, we're going to go look back at our balanced equation and realize that, oh, hey, something to take a look at. For every 2 moles, we would have 1 mole. Where'd it go? There it is, 1 mole. So 2, 2, 1. That's important because you need to know the balanced equation in order to get this right. So now that you've converted from HNO3 to magnesium hydroxide, you're ready to move on to keep note that you now have this many moles of magnesium hydroxide. And then the last step is going to be, just like what we did before, use that mole value of magnesium hydroxide and divide it by the volume that you have used. And so, just like what we did before, moles over liter, that's going to give you a value of concentration. And then you check for sig figs, you find out you need 3 sig figs, it's 0.171 molar magnesium hydroxide, and then you box your answer and say, I did it, I'm good to go. Now, the last example problem we're going to go through is going to be this problem here. All right, example problem 13-11. Your goal is to determine the volume of a 0.200 molar solution of sodium hydroxide to titrate 100 milliliters of a 0.300 molar solution of HNO3. Strategy, same as before, but with a little twist. So the strategy says you will assume that if you neutralize the solution, then the moles of HNO3 is going to equal the same amount of moles of sodium hydroxide. You're going to calculate the number of moles of HNO3 and convert that to moles of sodium hydroxide and use that molarity to find the volume. So I said a lot, but you know, step one's still the same. You're going to write down the balanced equation. Here it is. Sodium hydroxide, HNO3, it's going to get you your products. Cool. Now keeping that balanced equation in mind, let's take a look back at step 2. What we mentioned earlier, find the moles of HNO3. Here's how we do it. You have your volume. You're going to multiply it by its molarity, the concentration that you're given, and then you find out you have this many moles of HNO3. Then we move on to step 3. Using those moles that we found, what we're going to do is that we're going to convert moles of HNO3 to moles of sodium hydroxide. And then you get your moles of sodium hydroxide. Step 4, with your moles of sodium hydroxide, you're going to find the volume by using the molarity to your advantage. This is different that usually we had moles on the top, but we flipped it. We moved it to the bottom. Why? Because we now want to cancel out moles. Moles on the top cancels out moles on the bottom. You end up with volume, with units for volume. And there you go. You have 150 milliliters of sodium hydroxide. Why did I use milliliters and not liters like before? Well, in the original problem, we were given milliliters, so we just kept things consistent. So with that said, I hope that you box your answer, you check your work, you check your units. But other than that, that's pretty much it. The only thing left for me to share is just the alternate solutions again. So, ladies and gentlemen, really quick, you can use either like the step 1, 2, 3, 4 method, or you can just do all of it all in one go. It's fine either way. Just make sure that you keep track of your units, you keep everything consistent. And with that said, you just have to know exactly what you're putting in for each step if you choose the alternative method. But either way, no matter which method you use, you should still end up with the same answer. In this last example problem, it's 150 milliliters of sodium hydroxide. So hopefully this video was helpful for you guys. Hopefully you guys got all the answers correct on the Edpuzzle. And so with that said, if you like what you saw, smash that subscribe button, click on the bell, and we'll see you guys next time.